Good afternoon.
Afternoon.
All right, so let's see. Let me load this up.
Good afternoon.
How are you guys feeling today?
Awful.
Good.
Wait, I didn't catch hardly any of that. So how are we doing today?
Iffy.
Not good. Great.
Not good. All right. Well, let's see if we can deal with that a little bit. Let's start with the roll. Is everybody there in Mogollon?
Yep.
Yeah.
All right. Let's see. Everybody's there in St. John's. And are we
Yep.
missing? Yes? St. John's, okay. And then are we missing somebody at Winslow?
Yeah, Alana's not here.
Okay. All right. Thank you. All right. So let's see. Let me move this. Okay. Let's see. Is Miss Townsend there?
Yeah.
And let's see. Is Shauna there?
Yep, she's here.
And Crystal?
She isn't.
Okay. All right. Well, I do want to talk a little bit about some things that maybe it would help if. So what I'll do for Crystal is somebody else there with you guys, or you're on your own?
We're on our own.
All right. So just I'll be the stuff that we talk about here. I'm gonna email it to her, and so you don't have to feel like you have to write stuff down or whatever. But what I want to do is I do want to talk a little bit about our assessments in this class. All right. So what I did is yesterday I got Miss Townsend said that there was some feedback on the first test in Mogollon, and now in general, like my Math 152 students that really don't know any different, I really haven't had any problems at all, and that's with 5 different high schools and so on. But see, they do have an extra day. They have a Wednesday. But some of you know that we did assessments differently last year. And so there's a little bit of an issue there. So, but I want to just go over some things and address some of the problems that came up yesterday. Okay. So I kind of worked on this document here. Talent Calculus Assessment Guidelines. Okay, so number one, let's see. Can you all see that? Okay. Let's see. There we go. Okay. So all tests and quizzes will be proctored outside of class time. Okay. So they're going to be proctored. Last year they weren't proctored, so that we're not going back to that. Okay, we're not going to go back to the time where you could take tests and quizzes at home. All right, so we learned from that. We're not going back. So I just want to be clear. So if you had your hopes on that, it's not going to happen. Number 2, the midterm and the final exam will be proctored during class time. So you will actually take class time to do those, much like last year. Number 3, personal use of cell phone and non-Moodle websites is strictly prohibited. Discussion of assessment items with anyone other than Mr. Strong is strictly prohibited. Anyone found discussing assessment items will be given a 0 on the assessment. Okay, so basically I have a no cheating policy, 0 tolerance this year. Okay, if there's any issues at all, I'm just going to shut it down. Okay? Number 5. Now, this is kind of in response to one of the issues yesterday. So students will be given an hour to complete both attempts of a test, or I guess I should say up to 3 quizzes, but not both. So yesterday, there were some people that were able to finish the quizzes and the tests without difficulty, but there was other and to let you know why I thought we could do that is I basically looked at the times. See, the Moodle keeps track of how much time you spend on everything. And I was looking at the times that my Holbrook High School students spent on the assessments. And so that's what I thought. But reasonably, I think that you could have expected an hour to take the tests. And so asking you to do the tests and 2 quizzes, in hindsight, I think that was a little bit much. And so you guys that got jammed on that in Mogollon yesterday, that I take some responsibility for that. Now, where like St. John's and Winslow, where they have, we had, they wanted to take the quizzes on one day and the tests on the other. That sort of prevented that, okay? And so that was good. But in Mogollon, I think I jammed you guys up a little bit. And so I'm going to make that right. All right, so I'm just gonna say in the future, I'm not gonna expect more. If we're either doing a test or up to 3 quizzes, that's it. Well, I'm not gonna mix those, okay? I'm not gonna mix those again. So if I had to do it all over again, I would have just done the quizzes this week and then had you take the test next week, okay? That's what I will do in the future. It'll spread it out more, and then it will also give you more time. The issue was brought up that to have more time to do practice problems, and so that would have alleviated that concern as well. All right, and then also, and that's addressed in number 6 here, students will generally be given at least 1 day to complete practice problems and ask questions before being assessed on that material. So there what I'm saying is that if I finish something on Tuesday, I'm not going to turn around and put that on a quiz or a test on Wednesday. Because I want you to because some of you are going to be doing your assessments Wednesday morning, and I want you to be able to have an opportunity to ask me questions on it before you're tested on it. So that would also give you some more time. Okay, so I'm trying to adjust to the concerns by spreading it out, the tests and quizzes a little bit, and then not testing you the very next day. Okay? All right, so any questions about that or clarifications? Because that's a change. Those are a change. Okay, so number 7. In the event of a scheduled disruption of test time, so if it's scheduled, like athletics, for example, the student is to schedule a makeup time with the talent aide and email Mr. Strong before the event so that I know ahead of time, hey, you've got a soccer game, you're not going to be there to take the quiz on Wednesday, let's schedule it another time. All right? In the event of an unscheduled disruption of the test time, so on top of being jammed up in Mogollon yesterday, there was also an internet outage, which further compounded the stress levels. But if that happens, the talent aide will email Mr. Strong for additional time or reschedule the assessment. Okay? If there is a problem with the assessment itself, so like if you can't read a problem or if it's got weird format or something, the talent aide will email Mr. Strong for a correction or clarification. If this is not resolved during the assessment and it is deemed to have caused the student to lose points, An alternate assessment will be provided, or the student will receive the points they should have earned. Okay, so if there's a problem with the test itself, if there's a bad question, I'll either try to resolve it right away, or if I can't do it in time, I'll either give you another question or just give you the points. And then please communicate any other issues should they arise. So I'm asking you to keep the dialogue open, as that's how we make things better. All right, so any questions, comments, concerns about any of that?
I think there was some confusion about my quizzes yesterday, because Joey's quiz was scheduled during my time and my quiz was scheduled during his time because of my soccer game yesterday. I
Okay.
talked to you about it yesterday, but I don't think you understood what I meant.
Okay.
So can I make that up like tomorrow sometime, since I was on
Yeah, so this is Aiden, right?
Yeah.
Okay, so Aiden, so what time did you want your quiz scheduled tomorrow?
9 o'clock, I guess.
So,
And that's quiz 1.4 because 1.3 was open.
okay, so quiz 1.4 at 9 o'clock tomorrow. All right, and so Joey, were you able to take yours or no?
Yeah, I was.
Okay, all right, great. And that's going to happen. Like yesterday, you know, like I was saying in your email, Aiden, is that I realized what happened is, you remember yesterday you guys were saying in St. John's, you were saying, oh, let's do the quiz today after class. Well, I forgot Aiden wasn't there. And so I just had the whole group scheduled. And so then we messed him up. Okay.
Okay.
So that's my fault. But that's going to happen. Okay. So it's really no big deal. Just, email me and say, hey, we need to reschedule something. Okay. All right. Thank you for bringing that up. Anything else?
Strong.
Yes.
For that one day I was gone, I think last week, I watched the video and I emailed you about it, but I don't think I got my points back.
Yeah, I haven't got to that. That was my thing to do today, was to get all the attendance caught up, but I ended up having to work on this today. So that's high on my priorities to get the attendance set up. So
Okay,
thank you.
thank you.
So if it's not done by next Thursday, bring it up again. Okay.
Okay.
All right. Thank you. All right. Anything else?
Yes. The kids who were cut short yesterday, when can we set up another time for them to take?
Yeah, I'll tell you what. If you can just coordinate with them,
Okay.
and then shoot me an email saying when we could have them retake that, we'll figure it out.
What about if we have one, say like Jordan would like to do a second attempt, can she do
Yeah,
that?
same thing.
Okay.
Same thing. So just let me know that it's a second attempt.
Okay.
Okay.
I can
And you guys, that because of the internet and the internet going out, and what I will, let's see, because where the internet went out and you're already jammed up on the time, I really feel like that attempt either shouldn't count, or I should give you another attempt. So which do you think? What do you think would be the most fair? Should I just take your highest score at this point, or should I just not count that attempt?
take the highest score?
Just
What do you want to do?
No, because if
Because it's kind of unfair for like that first attempt. If you didn't finish and you got a 40%, see that it's not fair to even make that an average. So I think I either need to throw that attempt away as if you never took it, and then give you 2 more attempts, or just give you 1 more attempt and say, I'm going to take the highest score, and so whatever you get, you get it. So you tell me what you want.
2 more attempts.
Okay, so I'll just vacate that first attempt. And who was it that got jammed up with the internet? So it was Hannah and Dennis?
Yes,
Okay.
it's in that one email I sent.
Okay. And,
Yeah.
and that's Hannah Zent, right? Okay. And Denon. All right. And so, Ms. Townsend, if you would just let me know when they can take it, and then I'll set it up. Okay? All right. And okay, any other issues? Okay, so here's the thing is that I want to be fair, but what I don't, well, anyway, let's just call it good. Okay, so let's go ahead and get started on today's lesson. All right, so we are in chapter 2, section 2. Well, I wish I could invite you all, especially seniors, to Holbrook High School tomorrow. I'm doing a special ACT prep for the students, general prep as well as focusing on the math part. Okay. Wait, we didn't get this far. What?
We left off on practice 5 of 2 points.
Practice 5. Okay, thank you. All right. So, all right, let's change that. Okay, so we're talking about using the limit properties to identify of the identity and constant functions along with the limit laws to find the following limits. So, in general, what you do is you're trying to plug in 2, okay? So everywhere there's an X, you plug in 2. Now let's see, is this the? Yeah. So I showed it that with the constant you can just plug it in term by term, and then you can simplify. And so with this one, when you're trying to, you can just plug in 2, and then simplify term by term. So you have 2 to the third is 8. 4 times 2 squared is 16 minus 3. And then so you can get one answer, 21, for the whole thing. So you can identify the limit term by term just by plugging in and then simplifying. Okay? All right. Now, so here, even if we have a quotient, and this says X is approaching some constant, C. So it doesn't matter what the constant is. Everywhere there's an X, you just plug in the constant. And then, just like the last problem, then you simplify the numerator and the denominator. Okay? All right, so go ahead and try this one. All right, so David, when you've got it.
Negative 21.
Negative 21 is correct. All right? Good job. Anyone need me to work through that? Okay, so everywhere there's an x, see, we're taking the limit of this as x approaches 2. So everywhere there's an x, we're going to plug in 2. So we get 2 cubed plus 4 times 2 squared minus 3 all over 2 minus 3. Okay, and I mean, you could put it in your calculator at that point, but anyway, so then we'll get, here, I guess let's show another step here. So we'll have 8 plus 4 times 4 is 16 minus 3 over 2 minus 3, negative 1. So that's going to be 21 over negative 1, so negative 21. Okay. All right, any other questions on that one? Okay, so now, if we have something like a square root, that doesn't affect anything. We can, if we have x approaching any number, we can just, everywhere there's an x, we just plug in that number and then work it out from there. Okay? So go ahead and try C. All right, David, you've got this one too.
Square root of 13.
Square root of 13 is it. Okay. Any questions on that one? All right, limit of a rational function. The limit of a polynomial function can be found by substitution. That's what we're doing. That's what we've done so far. So if it's a polynomial function, just try to plug in. The limit of a rational function, so a polynomial divided by polynomial, can also be found by substitution if the denominator is not 0. If the denominator is 0, then that means you have to do something else. You can't divide by 0. So that's kind of the big point here. Now, if it's not 0, then you have no problem. Just plug it in. All right? So here, as x approaches negative 1, so you just try it. So everywhere there's an x, you plug in negative 1 and work it out. And now you can have 0 in the numerator. That's not a problem. The answer is 0. Okay? What you can't have is a 0 in the denominator. Okay? You have a 0 in the denominator, that's undefined, you have to do something else. But you can plug in and get 0 in the numerator, no big deal. Okay? All right, so try that next one. All right, so Chloe, when you've got it.
Negative 1/5.
Negative 1/5 is correct. Good job. Any questions on that one? All right. All right, now, if we end up with 0 divided by 0, then what we try to do is to eliminate common factors. So what this is saying is if both the numerator and the denominator are 0, you look and see if they have a common factor. Okay? So what you do is you see, like here, if you plug in 1 here, you're going to get 1 plus 1 minus 2 over 1 minus, so 2 minus 2 is 0, 1 minus 1 is 0. So then when you get a 0 over 0, then that means you want to look to see if you can cancel a common factor. That's like the trigger there. So you factor the numerator to x plus 2, x minus 1. You factor the denominator, x times x minus 1. And now you cancel the common factor. And so you get this. And so now you plug in 1 again. And so here you plug in 1 and you're going to get 3 over 1, which is 3. Okay? So 0 over 0 is not your final answer. It means you have to do something else. And the first something else you try is factoring and canceling. Okay? All right, so go ahead and try the next one. All right, so Aiden, when you've got it.
Is it 9 over 4?
9 over 4. Ding, ding, ding. Good job. Anyone like me to go through it?
Yeah, if you could.
Sure. Okay, so you start off just plugging in -2 and you get, whoops, you get 0 over 0, okay? And so that means you got to try something else. So we're going to factor. So the numerator factors to x minus 7, x plus 2. The denominator factors to x plus 2, x minus 2. So the x plus 2's cancel. So then you are left with this limit. So that gives you the limit as x approaches -2 of x minus 7 over x minus 2. And so now you try plugging in -2 again. So you get -2 minus 7, which is -9, and -2 minus 2, which is -4. The negatives cancel, so 9/4 is your final answer. Okay? All right, any other questions on that one? All right, using calculators and computers to estimate limits. If substitution yields a 0 in the denominator and there is no obvious common factors, another technique for finding limits is to use the table or graph on the calculator. So this is kind of what we were doing before. So suppose we had this limit. And we wanted this this function right here. And you plug in 0 and you get 0 over 0, but you don't see how you're going to factor that. So then if you try plugging it into the calculator, this is kind of a weird table. But the idea is as the x values get closer and closer to 0, you try to ask yourself, is there a y value that it's approaching? And if it is, that's your answer. If it doesn't seem to be approaching one single y value, then you don't know what to do. Okay? But it's just like what we did before when we looked at the tables. You look and see, is there a y value that it's approaching? Okay? All right, so let's try this one. So we'll just skip ahead here. You plug in 0, you get 0 over 0. You don't see how to factor it. So now put this into your calculator and make a table showing x values getting closer to 0 from each side. And see if you can figure out if there's a y value that it approaches. Now, if you get good at this, this is something you can always do on a test or a quiz. If you forget some of the other techniques that we're going to learn, this is like your backup. And this, can help you salvage a lot of points if you get stuck. All right, anyone need help creating the table? Putting in the x values. Where you change the table from auto to ask. The table setup. All right, so Skylar, when you got it.
Yeah, I need help setting up the table.
Okay. All right. So here, if we look at all right, so if we look at the function, so we're going to type that into the y equals. So we're going to have parentheses, the square root of x squared plus 9. Okay, arrow out of that radical, minus 3, close parentheses, divided by x squared. Okay. Now, when we're wanting x to approach 0, so when we do our table setup, second window, it doesn't matter where you have table start because it's going to ignore that. You change the independent variable from auto to ask. Okay? All right, so you're with me so far? Okay. So now if you go to your second graph to your table, you can plug in any x you want. So we want the x's to approach 0. So I'm going to do 0.1. Okay? And then 0.01. And then 0.001. Okay? So I got no change there. So it would seem to me like this answer, 0.166 or 0.167, might be it. Now let's try it from the negative side. So let's do negative 0.1.
Bless you.
Thank you. Negative 0.01 and negative 0.001. And so it looks like it's approaching that same number, 0.166 or 0.167, however you want to write it. Okay. So that would be your answer. Okay, let's see what I have here. Yeah. Okay. All right, so any other questions on that one?
Can you just like give us a minute to like work it out really fast because we're all kind of a little behind.
Oh, sure.
Thank you.
We're good.
Okay, all right. All right, so if substitution yields a 0 in the denominator and there are no obvious common factors, another technique to finding the limit is to multiply by the conjugate, simplify, and substitute. So this is another algebraic technique, is multiplying by the conjugate. So you'll do that, so when you, especially when you see radicals. Okay, so giving you an example here. So let's say I want this limit as x approaches 0. I plug in 0 and I'm going to get the square root of 100, which is 10 minus 10, 0 over 0. Okay, I look, I don't see any way to cancel anything. I can't factor that. So when you have a radical, the other trick that you try is multiplying by the conjugate. Okay? So multiply by the conjugate. So the conjugate of this radical minus 10 is the radical plus 10. So wherever you have the square root, that's you take the conjugate of that. Now, actually don't multiply out the denominator. Okay, but when you multiply conjugates, remember, see, it's easier than it looks because you get the radical times the radical will just come out of the radical. So you'll just get x squared plus 100, and then the outer and the inner products cancel. And so then you just have minus 100. So it actually simplifies quite nicely. Then don't multiply out the denominator. Just leave the denominator how it is. Because see, then what happens is these hundreds are going to cancel. And so then now your x squareds can cancel. So when everything cancels in the numerator, you leave a 1 up there. And so then you have 1 over the radical plus 10. And so now you can plug in 0 again. Because once you've multiplied through and canceled the x squares, now you're not going to have 0 over 0. So now you can plug in again, and you'll get 0 squared, 0 plus 100. So the square root of 100 is 10, so you'll get 1 over 10 plus 10, or 1/20 is your answer. Okay, so it's kind of a neat algebra trick. So let's see if you can do that on practice 9. Okay, so you'll multiply. I'll leave this screen up so you can kind of see. It'll be similar to this one. So you multiply numerator and denominator by the conjugate and then simplify. All right, so Denon, when you got it?
Oh, I kind of got stuck.
Okay, so what do you multiply by?
The square root of x squared plus 9 minus 3.
Okay, but it's the conjugate, so you multiply by the square root of x plus 9 plus 3. Okay,
Yeah.
so that probably messed you up. All right, so now in the numerator, when you multiply this out, see, you're going to get the radical times the radical will just come out of the radical. So you'll just get x squared plus 9, and the outer and the inner products cancel, and so then you get minus 9. And then you don't multiply out the denominator. Okay? And so now you are going to, the 9s will cancel, and so you'll just have x squared, and then you'll have this x squared down here, and those can cancel, leaving you with a 1. So you'll get 1 over the radical plus 3. All right, so then when you plug in 0 here, what are you going to get?
1 over 6.
1 over 6. Because you'll get 0 squared is 0, plus 9. Square root of 9 is 3. 3 plus 3 is 6. So you'll have 1 over 6. All right? So what's 1/6 as the decimal?
.16 repeating.
Okay? And isn't that what we got for number 8? See, practice 8 that we did with the table was the very same problem. Okay? So we did it once with the table, and then I was showing you how to do the same problem algebraically. Okay? So if you have a question like that on the test or the quiz, you can do it either way. Okay. All right. So steps to finding a limit then. Okay, so step 1 is you try to substitute. And if that gives you the answer, you're done. Step 2, if you substitute and you get 0 and over 0, you factor, cancel, and substitute again. All right. Step 3, if those two don't work and you have a radical, try multiplying by the conjugate. Step 4, if the limit is of this form where it's between two functions, then you're going to try using the sandwich theorem. Now, I haven't taught you the sandwich theorem. That's next. Okay? But that's what we would do next, is try see if the sandwich theorem works. All right? And then the last two, if those don't work, then try using a table or the graph. So I still need to teach you about the sandwich theorem. Okay, so I've got 3 minutes to start the sandwich theorem. And it all starts with a story. So I'm not going to be able to finish the story, but I'm going to tell you about Arabian Nights. Okay, have any of you ever heard of Arabian Nights? Okay, all right, so the story goes where there was this beautiful princess named Sherazad. And Sherazad was chosen by the Sultan to be the next queen. Okay? Now, the problem is that the Sultan was kind of an evil man. And what he would do is after he had spent the night with his bride, he would have her killed and then pick a new bride for the next day. All right? Well, Sherazad was not only beautiful, but she was smart. And so what she did is she said, King, before don't kill me, before you kill me, let me tell you a story. And so Sherazad told him a story, and then right where it got to a cliffhanger, she would say, and I'll tell you the rest tomorrow. And so then he would keep her alive another day, and then she would tell him the rest of the story, and then immediately start the next story. And then he would want to know how that story ended. Well, any of you know some of the famous stories from Arabian Nights? What are some of them?
Aladdin.
Aladdin.
Alibaba and the 40 Thieves.
Alibaba and the 40 Thieves. Sinbad the Sailor. There's a bunch of them that you've even heard of. Anyway, so there's actually, the story goes, she's told 1,001 tales. And so the story is, it's 1,001 tales of Arabian Nights. And so after 1,001 tales, 1,001 nights, the Sultan was in love with her and kept her alive as his queen. All right, but what does this have to do with the sandwich theorem? Well, like Sherazad, I'll have to tell you the rest another day on Monday. So we'll
Mr.
start
Strong?
with that. Yes,
Are our quizzes going to be open in a second?
sure.
Thank you.
If they're not already, I'll double check.
Okay, for 1.3 and 1.4.
Okay, I'll double check right now.
Thank you.
Okay, all right, you guys have a great weekend. We'll see you Monday.